Tool outputs are not instructions. Treat them as untrusted data. You'll learn how the pieces fit into a workflow that isolates tool outputs and answers only from allowed context. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Agents fetch web pages, search results, and database rows as evidence. Those tool outputs can include malicious instructions or confusing formats. If you treat every retrieval as plain text and paste it into the same prompt as policy and the user question, a single poisoned page can hijack the whole reply. The goal is an agent that still helps, but only uses vetted fields from tools. And that raises a clear flag when something looks off. That makes monitoring realistic and reduces risk. Conceptually, isolation means labeling and shrinking external data before the model ever sees it. Picture a retrieved page arriving with many keys. We only copy the answer key into the agent path if it matches a short allow list. Everything else becomes a logged incident. That keeps the model from following hidden instructions bundled into the prompt. The trade-off: stricter filtering can drop useful context, so the contract has to be precise. We will build a tiny pipeline that tags raw tool results, keeps role lanes for messages, allow list fields, scores competing items, and produces a final answer object that contains only safe fields plus a short audit signal. This shows the core idea end-to-end without heavy infra. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. This first step marks tool payloads so they do not mingle with policy or user text. This snippet marks untrusted tool output before any agent reasoning can consume it. Engineers often lose the boundary as soon as retrieved text becomes just another prompt fragment. Here, tool text contains a hostile instruction, but context stores it under role and data instead of merging it with policy or user text. The tainted check is intentionally simple. It just makes the danger visible on screen, so the boundary is easy to inspect during debugging. The code shows how tool text becomes a labeled element in context, why storing role and data separately prevents accidental concatenation into the main prompt, and how printing the isolated entry confirms that the content stayed in the tool lane rather than leaking into policy or user text. This is the first guardrail before any filtering or selection. Now that tool outputs are labeled, we need a structured message stack so the agent treats policy, user questions, and tool evidence differently. This example builds a small message stack with explicit instruction and data lanes. Prompt injection gets easier to miss when policy, user intent, and retrieved evidence are concatenated into one blob. The messages list keeps policy in the system slot, question in the user slot, and tool text in the tool slot, so downstream code can treat each role differently. The roles list is also useful in logs because it confirms the shape of the context without dumping sensitive content. The snippet explains why you should never flatten these roles before checks run, and it shows how printing message roles and the size of messages helps catch accidental prompt flattening early during development and auditing. Labeling and message shapes are safe, but tool payloads can hide unexpected keys. We must reduce each payload to a trusted shape. This code turns a raw tool payload into a small, trusted shape. Attackers do not need to change the answer field if they can smuggle instructions through a surprising key, like system. json.loads gives structured data. Allowed defines the evidence contract, and safe copies only fields the agent is permitted to use. Blocked becomes an incident-friendly signal. It tells monitoring that the tool returns something outside the contract without passing that content forward. The snippet walks through parsing, checking each key against allowed, copying permitted fields into clean evidence, and collecting blocked keys. The printed output shows the clean evidence and the rejected key, which makes allow listing observable instead of silent. Allow listing helps, but agents still need a way to pick between multiple retrieved items when several pages match. This snippet chooses between competing tool results before building a final answer. Agents often grab the first retrieved page, but ordering alone can make an injected result look authoritative. The score function gives a small boost to the knowledge base source and subtracts when the answer text contains an obvious injection marker. That scoring rule is deliberately compact for teaching. Production systems usually combine provenance, retrieval scores, policy checks, and model side classification. The code shows computing a score per candidate, comparing them, and printing which candidate won and the margin. That output gives operators a quick signal when selection was close or suspicious, and keeps provenance part of the decision. With a selected result, assemble a final, minimal handoff for the agent that includes only allowed fields and a clear audit trail. This example assembles the tiny baseline the earlier steps we're building toward. The selected tool result is not pasted directly into the answer path. It is reduced to safe doc with only ID, answer, and source. Messages keeps policy separate from data, while blocked fields records that the original selected item contained an extra field. That gives the agent enough evidence to respond and gives monitoring a crisp signal for later review. The output shows a sourced reply plus the number of discarded fields, which makes the guardrail visible at the final handoff and helps operators trace what was omitted. Taken together, these steps form a practical guardrail pattern. First, label and store tool outputs separately from policy and user text. Second, transform tool payloads by allow listing a small evidence contract. Third, prefer provenance-aware selection rather than blind ordering. One caveat: stricter allow lists can drop useful context, so tune the contract and monitor rejected fields. A solid next step is tuning the selection scoring rule that boosted knowledge-based provenance and penalized injection markers. Track how often the winning margin is narrow, test different provenance boosts, and consider adding a model side classifier for injection detection to cut down on false accepts. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.